Good afternoon, everybody. Thanks for coming. My name is Hongbo. I worked on the BuckleScript. So today I'm going to talk about what we have been doing in the last year and what I plan to do in the next couple of weeks. And I also be happy to take your feedback to see if we can improve in the future. Yeah. So just to give you an idea of what's the BuckleScript, actually it was made in 5 years ago when I worked in Bloomberg, and the original goal is to write a compile OCaml to debuggable JavaScript code. It's a bit subjective to say what I mean by debuggable or readable, but the idea is you want to make sure the generated JavaScript code is still very good. I mean, you want to allow people to read the generated JavaScript code, and it's a there's no concrete metrics, but we want to keep improving the quality of generated code. And the second part is when we made the BuckleScript, is like it's not like the escape hatch of the JavaScript ecosystem. Actually, it's brought with love for the JavaScript platform. Actually, I'm a very big fan of the JavaScript platform, including all the JavaScript tools. But we want to enable the platform to make it more powerful. The thing is, JavaScript is a very socialized language, which means you can write code in your browser and send a link to your friends and share what you have achieved instantly. But you want to make it more powerful means like JavaScript is still a dynamic language, and in my life experience of the programming, I mean people may disagree, but I do believe the dynamic language doesn't scale, which means if you have a large application, it will be a nightmare to refactoring later after several months. So to make the platform more powerful, that's why we made this project. There are 3 goals we want when we make the project. Is 3 goals we keep in mind. The first one is the reliability. So reliability means it's manifested in several aspects. It's not just the first is the reliable of the type checker. So it's not like the half-half. When you have like the program type checked, you don't want to have like something like runtime errors. You don't want to come across a runtime type errors. So you want a reliable type system, not like the just give you a better code completion, but you want to make sure that the error checking is exhaustive. The other fact about reliability means we want to use the reliable tool chain, which means when we have to make a choice between the fancy tools and the robust old-fashioned tools, we prefer the later one. I mean, we want the tool chain is reliable, not fancy, not just fancy. The second property we want to hold is the quality. Actually, this is one of the top priority what I have in mind. But the quality means in several aspects. It means the compiler has to be fast, and the generated code has to be fast. Not only be fast, but also being readable. Why I have this goal is because back to 2015, there are already some compiled to JavaScript language. I mean, even including static languages. But the thing is, for example, in like the ELM, when you want to make your code efficient, when you want to write games in the browser, so the advice is to write raw JavaScript code. But it's a bit embarrassing because when you have write code in a static type language, it's supposed to be faster than the dynamic language because the compiler has more information to optimize. So we want to make the generic code as faster or even faster than the handwritten JavaScript code. This sounds like the impossible because in the end of the day, you still compile the code to the raw JavaScript code, right? So it sounds like impossible to generate faster code than handwritten, but it's possible because you can write the JavaScript code, but it's not maintainable. The thing is, it's very easy for a compiler to maintain the environment of the choice is compared with the handwritten code. I'll give you one example. So in JavaScript just-in-time compiler, we create object with a shape of the dictionary. For the handwritten, it's very hard to keep in the same order shape following the same order. So you have like two fields, field A, field B. If you flip order, field B, field A, then you will fail the inline cache of the just-in-time compiler. But for the native compiler, or for the JavaScript compiler, it's very easy for us to make sure the record is always in consistent style. So, and there are a lot of other places. So it's our very ambitious goal to make sure the generic code is as efficient as the handwritten JavaScript code. At least it gives you an option to write the code in a very specific style to make sure it's as efficient as the handwritten JavaScript code. The last but not the least important one is the scalability. So we want the technology to be scalable on day one. So what we mean by scalability is like so it's holding if you start BuckleScript in a small project, it works. But if you have like boot style monorepo, it's still like give you instant feedback. The compiler and build system has to be fast to always give you instant feedback, no matter how large the repo it is. So, what's BuckleScript? A common misconception is that BuckleScript is a compiler, but it's not the exact answer. The answer is the BuckleScript is the build system plus the compiler, because for the user, it is very rare for user to call the compiler directly. The user has to use the build system to build the project. So the build system actually is a client-facing part of the tool chain, right? So very few people will call the BSC compiler directly. They mostly just call the BSB. And because we want to own the end-to-end experience for the BuckleScript users, we also own the build system on day one. Otherwise, when you have very fast compiler but you have very slow build system, then the whole pipeline will be screwed. So yeah, so that's why we also ship the build system on day one. To give you an idea of how the build system diagram is, this is a simplified diagram of the build system. So suppose you have like two files. One is a.ml, which is the implementation file, or a.read. The other is the a.mli, which is the interface file. So the build system will first take the source language and get a binary ASD for each file. This part for the parsing is the context-free parsing, which means it can be highly parallelized. So parsing a.ml and a.mli doesn't need to go to other dependencies. Then we take the binary ASD and generate the depth file which is called a.d. a.d lists all the modules which A depend on. So the build system will build its dependency first, and then with all dependency built, we try to build a binary interface file, a.smi, and once you get a.smi, then the compiler will do the real compilation. The real compilation compile the binary ASD, a.ml ASD into the a.js. And just and not just the a.js, you will also produce the a.smj. a.smj store some binary information of the module, like the arity of each function and the body of each function for optimization, like the cross-module inlining. So if you store the body of the code, then you can, when you compile another module, you can just inline the code. And here there's some design choice, like because OCaml has like the binary interface file, so it gives you a good idea of the separate compilation. Here from the diagram, you can also see this is in BuckleScript is a module-to-module compilation. It's not like the other like the JS OCaml, which means you compile all your code into a single file. But in BuckleScript we only support the module-to-module compilation. So one common question I received is why we not reuse the dual build system, which is a native one. There are multiple reasons for this. The first one is it's a bit different from the native compilation, because in native compilation we generate the binary artifacts. You can shuffle the files into different directories, and then make sure it's in your include path -i, which is including -i. Then you can put the binary artifacts everywhere, anywhere. But that's not the case for the JavaScript backend, because the two most popular multi-system in JavaScript is ES6 and CommonJS, which is both the file path sensitive, which means when you generate JavaScript files, you also generate the relative path in your generated code. If you shuffle around the files, then it will be broken. There's one module system which is indeed the file path insensitive, which is the Google module system. But I guess maybe nobody here even heard about the Google module system, and it's not very popular in the JavaScript community. So we have something different from the native compilation. There may be one simple solution is you can always generate the JavaScript file in a single directory, but that's not scale, because when you have a large project like the tens of thousands files, you generate all the files into a single directory, which means in most file systems, the file I/O performance will be degraded when you have a large directory which contains a lot of files. So that's not a scalable solution. To conclude, just compilation, the build system is the challenge is a bit different from native. Yeah, the other, as I mentioned, we want to own the end-to-end experience. So to own the end-to-end experience, we have to take over the build system instead of delegate it to other people. Yeah, so this is part of the build system. It's a diagram of the compiler. So you can see, as you can see, it's a multiple phase compiler. First, we take the source language, then we do the parsing and get the surface syntax. Then we do the type checking and get the typed syntax. Then we do the pattern match compilation, which eliminate the pattern match, and we also eliminate the modules and classes. Then we go to the raw number expression. From here, we compile to the JavaScript IR, which is a very small subset of JavaScript code. Then we image the text output of the JavaScript code. On the parsing stage, we also have the reason-conf parser, so we can switch between different syntax. Actually, it's extensible. The BuckleScript build system supports arbitrary syntax via the PP flag. The most common one is the reason-conf and the vanilla OCaml. On the later stage, in the type checking and the pattern matching, we do quite a lot of patches to the original OCaml compiler to get more information passed down to debug to help us to achieve the goal, which is generating the debuggable JavaScript code. The other two branch is the bytecode backend and native backend. Yeah, so this is pretty much a very brief explanation of what's the BuckleScript. Now I want to share with you about the current status in the latest release. So latest release is 5.2.0. As I mentioned earlier, we want to generate the debuggable JavaScript code. We are very close before this release, but after this release, I believe the goal is completed, which means in 99% of the case, the compiler generates the JavaScript code which contains no magic number, which means you can basically debug the generated code without any special help. Here is a diff of between the latest version and the last version. As you can see, the right side is a OCaml piece of code, which is the str function. Do the stringify the expression e, and you do a pattern match with the expression of e. If it's numeral, plus, minus, times, divide, negate, or variable. Previously in the generated code, it would generate the pattern match, compile the pattern match into a switch branch, but it's all magic number. But it's no longer the case. We generate the magic number together with a comment, say what's the name of the constructor. So this is very helpful if you debug the very large pattern match expression. Here it will guide the generated code. Actually, I think this is the most remaining piece where we generate the magic number. In other cases, like when you create a variant of OCaml variant, we always generate the comments. We say which constructor it is. Another very cool stuff is we compile the local module also into the dictionary. Previously, we take the global module and local module in a different style. For global module, it's compiled to a JavaScript module, but for the local module, it's an array. Here's a diff I show the difference. In the OCaml standard library, in the pervasive module, there's a local module which is called large file, and there are several functions. Before this release, we have created a large file as a variable, which is basically an array. And you can see it's essentially magic numbers. But in this release, we create JavaScript objects with meaningful names. This is very helpful because it makes the module system much more usable in the JavaScript land. Not only correct, but also easy to understand. And in particular, for OCaml, it has a very unique module system, which it has like the high order. It allows you not only do the abstraction over module, it also allows you to do the abstraction over high order modules. So with this better generated output, you will unlock a lot of use cases. Allows you to use one of the most advanced features of the OCaml language, the module system. And the OCaml module system is very powerful. Actually, there's no counterpart in other ML-like language. I believe the major difference between OCaml and F# or Haskell is like OCaml has a very unique module system which allows you to structure large applications. Within this release, the advanced module system will be more useful to BuckleScript JavaScript backend. It's not only just compiled and runs, it also gives you a better idea of what it is in the generated code. As we said before, we pay attention to the quality of generated code. It's another example showing the improvement in the compiler. So the left side is the OCaml code. you should define a type T, which has only one constructor full of the triple int times int times int. And then we have a function called shoe, which pattern match different pattern. If it's all zeros, we generate the zeros. If it's not zero, we do the string concatenation. And the right side is the general code. As you can see, you will see a match variable called exit. And this exit comes from in the internal of the compiler. It has a lot of static jumps and static cache. Because the compiler used to do such things in a very uniform way. So in this release, we add some data flow analysis and to remove the static jump and cache if it's redundant. And you can see this is a new output. The same OCaml code, just simply generate better code. It's pretty much like the handwritten code, but without, this is not easy because from the compiler engineer point of view, when you take the source language, you do the compilation in a uniform way. I give you an idea of if you don't do any optimization. Take this example. This is from, a non-optimizing compiler. You can see for non-optimizing compiler, the generated code will be very, very verbose. Yeah, so we spend a lot of time to we will continue improving the generated code quality. And last but not least important is the build performance. In general, when you add new features and new optimization paths, your compiler will get slow and slow and slow. But the thing when we engineer the compiler, we are very careful to avoid the regression of the compiler performance. So actually, it got slightly faster in each iteration, because take for example, like in the last 10 months, actually we improved for the same project, which is has the 1,000 files. The performance actually is improved marginally, like 20%. This is not easy because the performance is already pretty good in the beginning of this year. So this just gives you an idea. We are very careful about not introducing regression of the build performance when we add new features. Actually, for this release, I want to say thanks to Cristiano. He made a lot of contributions to this release, like changing the data representation of have better comments. It's almost done by Cristiano. Yes, thanks. So the last piece is I want to share with you what we want to do in the future, because we have priorities, because we are not a very large team, and we can only work on we have to solve the priorities and do the things which we think most important. So the first thing is we have been maintaining 2 versions of the OCaml compiler for quite a long time. We maintain the OCaml 4.2 and the OCaml 4.6 for quite a long time. The idea is we will finish the transition in the next half year. So how to get it work is first we will do the development in the math branch against the 4.6 by default. And if we found no big regressions, no obvious regressions, then we will encourage people to use the 4.6. And once everything is on board, then we will switch to 4.6 by default. There's a couple of things to be careful is the PPX. So if you rely on the PPX or you are developing on the PPX, make sure you have the PPX works for 4.6 as well. Otherwise, I think one thing I have in mind is the GraphQL PPX. They're still only, if I remember correctly, they're still only 4.2. So Yeah, we will finish the transition very soon. I mean, in the next half year, the goal is to get everybody on board to use 4.6. And if you are not a heavy PBX user, I suppose should be the upgrade should be just one click. The other thing which we're not only targeting OCaml 4.6, we also do it sync up with the upstream compiler 4.09. The great thing with BuckleScript is because we are not inventing a new language, so you can still get the improvement in the upstream and get this benefit for free. So there are quite a lot. There are several fancy features in the upstream. One is the private, the open module, in OCaml there's a concept called open the module. In this operator open, you can only open M, the module name, but in the latest release of OCaml language, you can open the whole module language, which means taking advantage of this, we can have a private operator in the OCaml language without writing the interface file. Currently, if you want to limit access of some function, you have to write a separate interface file. But in the latest OCaml, you can limit the access of the functions without writing the interface file. I think it's a very, very useful feature, and we want to get this into the BuckleScript in the future, in the near future, because previously we don't upgrade very, very frequently, but we want to accelerate the progress. The other thing we want to do is compile the record into objects. As you can see, compiling the module to the object gives you a better output, and we want to apply the same pattern here. We want to compile record into objects. The current status is we compile record into array, but for each field we have some comments tell you the field name. So this helps you debugging, but it doesn't help you with the FFI. So if you want to import a JavaScript object, you still have to write some FFI. But if we manage to compile OCaml records into objects, then the FFI story will be much more simplified. You will also deprecate like something like BS.deriving stuff. The other thing we want to improve is improve the build system to separate the compiler from the standard library. This is a long overdue feature request, but there's some complexity involved because the standard library is built in a very ad hoc style. So currently the build system cannot manage the very ad hoc build of the runtime because all dependency is specified by hand. So we want to we don't want to jump like get this done quickly. We want to improve in a very stable style. We first make the build system more powerful to build the runtime standard library, and then we split the compiler from the standard library. So the idea is why we want to achieve this. The idea is to get you to use the BuckleScript wherever JavaScript is applied. The current one common complaint in place is that you have to install a very large library, very large package. But want to once we separate the compiler from standard library, then you only need to install the compiler for once, but the standard library itself is very lightweight. Yeah, that's the plan to work for the next year. Last part is BuckleScript is an open source project on day one. Actually, when I working in Bloomberg, and the goal is, and the open source is in the very beginning. Yeah. So we want more help from the community and also understand what the community requirement. So actually we made some item to improve in the last couple of weeks. First is for the repo itself, it's very easy to build. There's no not too many dependencies. As long as you have a C compiler, it should be able to npm install the repo of the master branch. So if you're interested, you can do the naturally build. In your project, you can test the naturally versions. The other thing we want to improve is make sure the onboarding experience for casual users, because we have to admit the BuckleScript project is still not mainstream. So most people will maybe only use it like after work. You have very limited time, like just 1 or 2 hours in the night, and if the onboarding experience is very difficult for the casual user, then maybe they just simply ignore or not trying it out. So onboarding the user experience for the casual user is also our practice. And yeah, so this is, and reach out to me if you have any concern. Which can be help the project to get more involvement with the community. Yeah, this is pretty much what I want to share with you today. Thanks.